Hi everybody. Here's the next installment of the C10 Making Links. We're going to look at what equilibrium is. You need to be able to explain equilibrium very simply in terms of its textbook definition, but you also need to be able to explain what that really means for a reaction. So here goes. Let's have a look at see if we can explaining what equilibrium is in terms of its textbook definition. The textbook definition is that equilibrium exists when the concentration of reactants and products remain stable. So the forward reaction is happening, the backwards reaction is happening, but they are happening at exactly the same rate. And that's why it links into rate of reactions and why we're recapping it. Try this analogy if you're struggling to get your head around it. Say you've got two workers here, worker 1 and worker 2, and worker 1 is digging a hole, worker 2 is filling that hole back in. Worker 1 would be the forward reaction, he would be making the products. Worker 2 would be the backwards reaction, making A and B again. He would be C and D, making A and B again. Now say worker 1 is shoveling at exactly the same rate out as worker 2 is shoveling in. That hole would never get any bigger. That pile of dirt would never get any bigger. That hole would never get any smaller. 2 would never ever fill in the hole. 1 would never ever make a bigger hole. So both would be shoveling, both would be getting very tired, but if we zoomed out over time and we looked at the change in the size of hole or the change in the size of the pile over time, it wouldn't get any different. In fact, the size would remain constant. Well, equilibrium is exactly the same as that. A and B are working really, really hard to change into C and D. C and D are working really, really hard to change back to A and B, but the overall concentration of A and B and C and D remain constant. So lots of people think, okay, then they must be the same. We must, at equilibrium, have exactly the same concentration of A and B as we do C and D. Well, that's not necessarily the case. Just because they remain constant doesn't mean that they will be exactly the same. Have a look at this. It might be that they are exactly the same. This is the forward reaction. Hydrogen plus iodine making hydrogen iodide. So this would be the forward reaction here. We would start off with an awful lot of H2 and I2. That level would drop over time as we start to make the hydrogen iodide. That level would drop over time and would eventually remain constant. In the backwards reaction, I2, HI, going back into I2 and H2, we would start off with none because we only had reactants to start off with. The levels would rise until eventually we reached equilibrium. So this would, when we get a flat line on a graph like this, that's because equilibrium has been reached and the concentration is not changing anymore. So in this case, the amount of reactants and products is the same. But in this case, let's say the amount fell of H2I2, but in this case, the amount of HI rose. Actually, we don't have exactly the same concentration. We end up with equilibrium shift very, very much to the right-hand side. So we are making way more products than we had reactants to start off with. And this is normally what happens. But we could have made some changes, which we'll look at later, but we could have made some changes and we've shifted the equilibrium here. In fact, we're making way more HI than we are the backwards reaction. The forwards reaction has progressed more. We've shifted the equilibrium, but you can still see there is no further change. We've hit equilibrium here. So what must happen in order for equilibrium to be reached? There's 4 criteria that we need to fill. First of all, the system must be closed. We cannot have it so that we're drawing off the HI. If we were drawing off the HI, then we would be shifting the equilibrium constantly. So if we want equilibrium to be reached, if we want there to be no further net changes, we need to make sure that the system is completely closed. We need to make sure that both the forward reaction and the backward reaction are still progressing. If only the forward reaction happens, and there is no backward reaction, equilibrium only exists in reversible reactions. The rate must be exactly the same. So that is, in a nutshell, equilibrium. The concentration doesn't change because the people are shoveling at the same rate, if you like. And the amount of reactants and products do not have to be equal. Okay, they must be constant, but not equal. So that's it for equilibrium. Next, we are going to look at how we shift the equilibrium.